Okay, here we are at 18 intervention. And this is a circumference problem. So this is all about circumferences. So the first thing that I'm going to do, anytime I look at it and I see, oh, this is about circumference, I'm going to go ahead and write that formula down. The formula for circumference is equal to 2 times, and I don't really need to put the time sign there, 2 times pi times radius. So since I know what 2 is and I know what pi is, I know to solve this, I need to figure out what the radius is. So my first step is I'm going to draw my tires. So they tell me first that I've got a tire. That's not a very perfect tire, but it's going to be close enough. I have a tire that has a diameter of 10. Diameter goes all the way across. I'm going to figure out for that if the diameter is 10, the radius is 5. I want to compare radius to radius. My second tire, I'm going to give myself some space. A little better. My second tire has a radius of 25 inches. Tells me so right there. Radius of 25 inches. So now I'm ready to figure out the circumference, because that's the type of problem it is. Remember, it's a circumference problem. So what they're really asking me when they ask this, they say, how many rotations will the front tire, this is my front tire right here, complete for every rotation of the back tire? This is my 25-inch back tire. So what they're really saying to me is this. If I compare how far around this is to how far around this is, how much bigger is the back than the front? How much bigger is the circumference of the back compared to the front? So I'm ready to solve that now. So for the front tire, I know that the circumference is equal to 2 times 3.14, because that's how much they told me pi was right here, 3.14, times the radius, which I said was 5. Now, I can do this in any order I want to. When you multiply, just think, if you multiply 2 times 3 times 4, 2 times 3 is 6 times 4 makes 24. If I change the order and do 2 times 4 instead, so let me just show you what I'm doing here. If I do 2 times 3 times 4, I get 2 times 3 is 6 times 4. I get 24. If I change up the order of that, if I say, heck, I'm going to do 2 times 4 times 3. Well, 2 times 4 is 8 times 3 is 24. And you might have guessed if I did the 4 times the 3 first, I'd get 12 times 2, 24. So the reason I'm pointing that out is it's great on this problem because I know what 2 times 5 is without any need for a calculator. 2 times 5 is 10 times 3.14. And anything times 10, you add the 0. So this front tire has a circumference that is 31.4 inches. That's my front tire. Let's go to the back tire. So for the back tire, I have circumference equal to 2 times 3.14 times 25. There we go. So this one's going to be 2 times 25 is 50 times 3.14. And now I'm going to need a calculator. So I'm going to grab a calculator here. Remember, we use real tools for real jobs. And I've got 50 times 3.14 equals 157. So this has a circumference of 157 57. So the question is, how many times does 31.4 go into 157? That front tire is going to roll. How much will it roll for each time the back tire goes around? So we want to know what's the circumference of the front tire. Grab my pen here. Circumference of the front tire, 157, divided by circumference of the back tire. Oops, excuse me. I said those backwards. I'm writing them correctly. Circumference of the back tire divided by circumference of the front tire. And I'm going to have 157 divided by 31.4. It's going to be 5 times. So what that tells me is this. That tells me the front rotates it's an S, not a 5. Sometimes hard to make S's with this. Rotates 5 times for each rotation of the back. So for every time that back tire goes around, the front tire will have gone around 5 times. Okay, so check your work on using circumference here. And then, if that's what you got, if you also got 5, then you're good to go. Check your work on the bottom. If you didn't get 5, go back and look this over and then rework the bottom as necessary. All right, here's our second problem. Jose and Maria each bought a unicycle over the weekend. I wonder how much time they spent in the emergency room. Anyway, Jose's unicycle has a wheel radius of 16 inches. Maria's unicycle has a wheel diameter of 36 inches. How much farther will Maria travel compared to Jose after 10 rotations of their unicycle wheels? So we're going to keep this, we have to keep this in mind for later, 10 rotations. We're not just going 1 time, we're going 10 times. So, Jose and Maria. Okay, so Jose's unicycle has a radius of 16. So let's get Jose's unicycle here. We're going to draw the wheel of Jose's unicycle. And it has a radius, so from the center out, 16. This is Jose. Let's just do that in pen instead of highlighter. This is Jose. Over here, let's do Maria. So there's her unicycle wheel. This is Maria. And what we're told is, for Maria's, the diameter, now remember a diameter is all the way across. It has a diameter of 36, which means if it has a diameter of 36, it has a radius of 18. So now, it sounded at first like these wheels were really different in size, but now we can see they aren't that much difference. Jose's radius is 16. Maria's radius is 18. That's not a whole lot of difference. So again, what we're calculating is how far around, or what is the circumference of this. Because when Jose's goes around 1 time, that's how much it will travel. When Maria's goes around 1 time, that's how much it will travel. Those both show circumference. So, time for a little formula work here. Once again, let me write it down. the circumference formula. Circumference equals 2 times pi times the radius. So when we do Jose, we've got 2 times 3.14 times the radius, which is 16. 2 times 16 is 32, so we've got 32 times 3.14. Let's bring our calculator back out. And we've got 32 times 3.14 is 100.48. Now that's each rotation. I'm going to remind you again. This problem asks us what happens after 10 rotations. So we have to keep in mind that's only one rotation. All right, let's show the calculator over here somewhere. Get it kind of out of the way. And let's do Maria's. So for Maria's, we have 2, because that's always how the formula starts, times 3.14. That's pi. But this time, it's times 18, because that's the radius of Maria's. 2 times 18 is 36 times 3.14. Bring my calculator back out. Come on, calculator. There you are. And we've got, let's clear it. Clear it. We have 36 times 3.14, and that is equal to 113.04. And that is also each rotation. All right, so now we've got a little more math to do here. Not a lot, but a little bit. So thing number one we have to do, we have to take 113.04 and subtract 110.48. So 113.04, check my work there, minus 110.48. I get 2.56. Then I need to take that 2.56, my calculator is kind of covering it up here, and I need to multiply it by 10. So this 2.56, each time for one rotation, that's the difference. For 10 rotations, the difference is 25.6 inches, which is about 2 feet. So after 10 rotations, Maria has traveled 2 feet further than Jose. She doesn't much get bragging rights for that. Okay, so now you've seen these problems. Again, if you're still a little unsure, if you haven't done it yet, go back. Let's scroll this up so we can see the concept right here. Go back and look at some of the past tests for 18.2. So that could be test number 18, 19, or 20. All of those tests will have concept 18.2 on them. If you still have questions, you can always bring them to me and I'll be glad to work with you.